Alright guys, hello. I'd like to go over the nth root test with you guys today, but first I want to talk about how I think about series convergence. So let's go back to our favorite series here. This series, alright, S, we know this converges to 2. And so what does that really mean? Well, if I think about having a number line, right, and this is the point 0, and this over here will be 2, and this here will be 1. I think of this series and each term in this series as taking steps. So the first term, takes a step of 1, right? The second term takes a step of 1/2, and then a step of 1/4, and then a step of 1/8, and then a step of 1/16. And so on. And as you take more and more and more of these steps, and as you add each one of these steps together, 1, 1/2, 1/4, 1/8, and so on, you are going to get closer and closer and closer to this value of 2. You're going to cozy up. Each term gets you closer and closer and closer. You're never going to surpass 2. You're never going to keep going on forever. You're going to get closer and closer and closer to 2. Okay, and that's what we mean by convergence. A divergent series, these steps would just keep getting bigger and bigger and bigger, and they would go on and on and on and on forever, and you would never actually end up anywhere. Okay, that's one way of converging. Other ways, of diverging. Other ways of diverging are just to kind of like hop around, positive terms going to the right and negative terms going to the left, and never really settling down and trying to get close to a particular value. Okay, so I'd like to talk about the nth term test. Okay, and this is a divergence test. This can only tell you if a series diverges. It does not tell you if your series that you have converges. Okay, so keep that in mind. So basically it says, given a series, let's use the series notation, n equals, now I can put down 0 here, I could put down 1, I could put down anything for that lower bound, but it's going to be an infinite series, and a sub n represents the general term. Okay, and the nth term test says if the limit as n goes to infinity of a sub n, so we're not looking at the sum, we're not taking the limit of the sum, we're not doing partial sums and the limit of partial sums, we're just doing the terms, what's happening with those terms. And guess what? If those terms don't go to 0, then we can say the series diverges. So in other words, all right, when you take the limit of those general terms, what you're basically saying is that those steps, when I draw that number line and I start out at 0, those steps have to get smaller and smaller and smaller. Each term is a step, and we're saying if the steps don't go to 0, if they don't get infinitely small as you add on these more steps, you're never going to have a chance to stop or get close to anything. All right, those steps could just be getting bigger and bigger and bigger. Even if the steps are the same, if every single step is the same, if we have the sum n equals 0 to infinity, and guess what? If your terms end up being like 1 over and over, then you're just adding 1 and 1 and 1 and 1. You don't even have a chance to converge. All right, it's only possible for you to diverge. So let me do an example here of this nth root test, and then I'll let you guys have at it, all right? So for my first example, let's say we have the series n equals 0 to infinity, and it's 4n cubed minus 2n squared all over 6n cubed plus 10. Now, if we just look at this general term and we take the limit of this general term, like what's happening to these terms as n shoots out to infinity, well, we know by the degrees, by pre-calculus, by some of the methods we learned with limits at the beginning of the year, that because the 2 degrees, should be squared, because the 2 degrees are the same, the limit of this is the ratio of those 2 leading terms, 2/3. Hang on. Starting to write poorly. 2/3. Okay? So that means as you go out, the terms might slow down, but they're not going to 0. It's almost like this series would constantly, if you go out far enough, it would look like 2/3 plus 2/3 plus 2/3 plus 2/3, meaning it's never going to stop anywhere. So because this does not equal 0, we say that this is going to diverge. Okay. Second example, really quickly, because I have to get online, start class. Let's take the sum n equals 1 to infinity. Again, it doesn't matter where we start. Okay, make this e to the 2n over n. Now, if we take the limit as n goes to infinity of e to the 2n over n, just looking at that term, well, this is really infinity over infinity. And anytime you have an indeterminate form like this for a limit, we can use L'Hopital's rule. We can go ahead and lope it. Which, when you take the derivative of the numerator and denominator, you get 2 e to the 2n over 1, which is infinite, meaning your terms get infinitely large as n goes to infinity. Therefore, it's going to obviously diverge because your steps keep getting bigger. So it's impossible. So there you have the nth term test. There's a couple problems. Try them out. And yeah, stop by my office hours if you have any questions. Thanks, guys.